Today we're going to extract DNA. What you will need for this is washing up liquid, whatever you call it, dish soap, isopropanol, you can get that in any pharmacy, sodium chloride, which is just normal table salt, then a tinier glass vial or something with a tight lid. You will need a tablespoon and at best a syringe to measure stuff. Also you will need filtering equipment, which can just be a normal coffee filter or just some kitchen paper towel or whatever. And what you're going to do at first is take 45 milliliters of water, just normal water from the tap, and mix it with 5 milliliters of the dish soap, and add 1 tablespoon of sodium chloride table salt. Mix it all together until it is a nice solution and all the salt is dissolved in it. And then you need to add the DNA to this. And what is probably the worst about this is taking the blood sample. I usually do this on my foot. Actually that didn't work because my veins are not good enough, so I guess I'll have to use my left hand. You can see a vein sticking out there. And I'm just going to let it drop into the solution. That's not for the faint of heart, I suppose, but it works. Okay, that should be enough. Let's stop this and then stir the solution. Nice bloody solution. And back in the kitchen, we're going to filter my bloody solution. This may take a while because the filtering process goes rather slowly. You can see the drop setting up. So let's just wait. I will then take a couple of milliliters from my blood solution and put it in a smaller vial. I'll use 10 milliliters and then really carefully add the isopropanol. 10 milliliters as well. I can see it here. Well, let's repeat the experiment as it is usually done. That is by using 45 milliliters of water with just a spoonful of table salt, because you will need to put this in your mouth and flush thoroughly and then spit it back in here to have some of your bodily cells inside the solution, and doing so with dish soap wouldn't be too pleasant, so we're gonna add that later. Anyway, let's add the dish soap, and again mix it. Again, pour the solution into a small container and add 10 milliliters or the same amount of isopropanol, slowly and carefully. And you can probably see that there are more strands coming up. They are really small and hard to see with my eyes already, so I'm not sure if the camera can pick them up, but you can see the one in the front quite clearly, I'd say. But on the other hand, look in this vial, there's not much happening. Why is that? Well, the thing is that blood mostly consists of water, and even, for example, the red blood cells, the erythrocytes, do not have a nucleus, so it means they do not contain DNA. The only cells in the blood that contain DNA are the white blood cells, and I don't know why we cannot really see DNA here. There are some very tiny fragments, I suppose. That could be DNA, but I guess the problem is that there are just too few cells inside this amount of blood. You would probably have to extract the white blood cells and extract the DNA from them. So this didn't really work, which is good news, because it means that you don't have to drain your own blood to repeat this experiment, but to just gargle with some salty water, which isn't too pleasant, but probably nicer than taking a blood sample for most people. You can see another bubble with DNA. Well, the camera can see two now, I suppose. I can see some more, but the camera can't. I will now try to get that bit of DNA here out and on the microscope slide, so we can probably see it under the microscope if we're lucky. Okay, so filming into my microscope doesn't work too well, but this little strand here is my DNA. Okay, here it is again, filmed through my microscope at a higher resolution. I think we're at something 600 resolution or something now, and you can see the strand of my dsDNA. Okay, there it is again with the zoom lens, and you can see quite well twisted here. I just found a very suitable source of light. Look at this. You can clearly see my twisted little dsDNA. Okay, so this is the absolute best I can do with my setup. This is at about a total of 1024 zoom, and you can see the twisted, god damn it. Anyway, and you can see the twisted strands of my DNA here. And if I zoom in and out a bit, you can see how it is twisted around itself. This looks quite cool as well, at a smaller zoom level again. It's beginning to look very whitish, because the liquid has evaporated and has sodium chloride bonding to my DNA.